So a function is a rule that takes an input, does something with it, and gives a unique or corresponding output. There's a special notation that we use in this type of situation. It's called f of x. It looks like it has the letter f to say, hey, I'm a function, with parentheses with an x inside of it. That x inside the parentheses represents the input. The f of x together, that symbol altogether, means the output. So when we had our charts or our tables before, we had an x on the left and our y on the right. The x represents the input and the y represents the output. We're still going to have our x input, but our output, we're just going to change the letter. Instead of using y, we use the f of x notation. So this notation right here to represent the output. It is read f of x, not f times x, as what it kind of looks like. So what is this notation, f of x? F of x, it is the output from the function, as I told you before, the y value, when it is a function, when the input is x. So you see inside parentheses it has the letter x. It's telling you that we're inputting x. So what exactly is g of t then? That is when our input is t value, whatever t is. Maybe it's tickets. And that g of t says, okay, this is what I get as an output when I put in t. So note that the letter f and f of x are different. F is the name of the function. We could use different letters. It's the rule. But f of x is the output from that rule when the input is x. You might understand it better if we actually have an example so that you can apply this. So here we have what looks like an equation. It is an equation. But instead of a y there, they have the f of x notation in front. Again, it's just a fancy way of saying y. It just identifies that this equation here is a function. And it says, what is f of negative 2? What they mean by that is, if you replace all your x's with negative 2, what do you get as an answer? So our input is negative 2. Watch what I'll do here. So I'll say f of negative 2. That's saying I'm going to replace all my x values with negative 2. So on the other side of the equation, I'll write negative 4 times negative 2. I replace that x with negative 2 plus 1. And then now I have this is all numeric now. This right here is all numeric, so I use my order of operations to simplify it. Well, 4 times negative 2 equals negative 8 plus 1 equals negative 7. So our input was the negative 2. And I kind of got ahead of myself here. So they said substitute. This down here, you folks, is what I did up here in the air. So just fill those in. And our output then is negative 7. When you see the word evaluate in function, it's just another way of saying, well, plug this number in and tell me what you get as the output. So plug in the input and get the output. So let's try this. Question number 1, we have the function f of x is equal to negative 3x plus 2 for x, and they want us to evaluate it for x of 3. So what we'll say is, with this function, so f of 3, what do we get as our answer? Well, we write negative 3 times our x value that they tell you to plug in plus 2. Simplify this. Negative 3 times 3 is negative 9 plus 2. Negative 9 plus 2 is equal to negative 7. So in other words, f of, sorry, my pen's not writing there, f of 3 is equal to negative 7. If the function notation confuses you, one thing you could do is just replace it with the letter y. So let me erase all of this for a second. I see students do this all the time. I told you that f of x is just like saying y. Y is negative 3x plus 2. And I want to know, what is y equal to when x is equal to 3? Well, y is equal to negative 3 times 3 plus 2. And we've already solved that. We said that y then is equal to negative 7. But because this is a function, it's a relationship, we should go, when you're all done, change it back and use the function notation. We said that we use this function and the value that we plugged in was 3, so f of 3 is equal to negative 7. If you use the method of changing the function notation to a y, make sure your final answer, you put it back in function notation form. Question number 2. F of x is equal to 5x minus 22. And they said you want to evaluate it for the number 12. So the function evaluated for the number 12, so f of 12 is equal to 5 times 12 minus 22. You have to multiply first. 5 times 12 is 60 minus the 22. Order of operations always says you have to do multiplication before you do any addition and subtraction. 60 minus 22 is equal to 38. So your final answer would be f of 12 is equal to 38. Now I did just notice in the directions, they want you to write the function as the answer as an ordered pair. So once you find out your function's answer, the ordered pair then would be the x value first. So in question number 1 would be 3, comma, your y value, negative 7. Question number 2, the ordered pair would be 12, comma, 38. So make sure you look for that in your directions, writing it as an ordered pair. Let's try another one, question 3. This one, the question is actually asking the same thing as before. Just look where it says, it says 4f of negative 7. In the previous question, I think it said x is equal to like negative 3, and that's the value plugged in. This is doing the same thing. It's just saying function of negative 7. So f of negative 7, oops, get my pen tool here. F of negative 7 is equal to, and then you copy down the rest of the equation down, but you replace all the variables with that negative 7. Alright, simplify it. Negative 5 times negative 7 is positive 35 minus 3. That reduces to 32. Again, they want to write our final answer as an ordered pair. So we would write our x value, or their input value, is -7. Our output value was the 32. In question 4, they basically said if I input 3 or I plug in 3, and they want to know what do you get as an output. Well, f of 3 is equal to 10 times the quantity. Okay, we're inputting 3 wherever we see our variable. So you replace that first x with 3 minus 2. Notice that every time I plug in or replace a variable with a number that I'm plugging in, I always write it inside of parentheses. Sometimes that's going to make a difference. Alright, order of operations says I need to solve for my exponents first. So 10 times, well, 3 to the second power is 9 minus 2. What do we need to do next? I see multiplication, that 10 next to the 9, and I see the minus 2. You have to do multiplication before you do subtraction, so it would be 90, because 10 times 9 is 90, minus 2. So our output then would be 88. Our final answer as an ordered pair would be 3, 88. Now you can turn to your guidance practice sheet over function notation. You can complete all the problems on the page. 11 through 15 are a little bit tricky, so be careful on those.